Hello everyone, good evening. Welcome to today's session. Okay, I hope there are no audio and video issues. If there is anything, please let me know. Okay, so welcome to MADHAV SANKAR classes, and today we are continuing with the CSAT series. Okay, we have already completed a couple of lectures. First one was a mere introduction. Second lecture, we started on operations on numbers. I explained to you how to find whether a number is divisible by a particular number and so on. The divisibility test. Okay, that was the main content of the first video. All right, and today is the part 2 of the same chapter. By today we will end this chapter, and in the next class we will do the HCF and LCM, a different topic altogether. All right. So in this lecture, we will be continuing whatever we studied in the previous lesson. We will be doing more questions on that. Along with that, we will also look into a couple of series, arithmetic progression and geometric progression. Very basic questions I will be showing, and then we will be doing more and more similar questions towards the end of the series. Okay, when we do a full mock on CSAT. Anyway, once again, welcome to MADHAV SANKAR classes. If you are new to this channel, please subscribe to this channel and share it with your friends also. Also, don't forget to like and comment on this video. Okay, let's begin. So, CSAT and operations on numbers, part 2. All right. To the new joinees, if there are any queries or questions or doubts, please feel free to put in the YouTube live chat and I will address it right away. Okay. Also, when we do problems, you can post your answers in the YouTube live chat. I will take a look into it and give you the, we will make it as interactive as possible. All right. So please, directly start with some of the important series first. This is not AP or GP, arithmetic and geometric progressions. These are some of the results that we need to know in order to do certain questions really fast. Okay. For example, this is the first important formula: 1 plus 2 plus 3 plus etc. all the way up to n. The sum of this series is n into n plus 1 by 2. Okay, say for example, 1 plus 2 plus all the way up to say 10. Okay, what is the sum of this? Either we can, add the entire thing from 1 to 10, or we can simply put it in this formula where n is equal to 10. So 10 into 10 plus 1 by 2 is equal to 55. Okay, so if we know this formula, we can easily, very quickly, without wasting any time, we can arrive at the answer. That is the advantage of knowing these kinds of series, the formula for these kinds of series. Okay, say for if n is here, I gave you an example of 10. Consider n is say 1000 or say 10,000. Okay, doing manually the entire calculation is very difficult. So we can easily substitute the same into this formula and arrive at the answer. So by heart these formulas. Okay, these three are very important. 1 plus 2 plus 3 all the way up to n. It is n into n plus 1 by 2. Second one, 1 squared plus 2 squared plus 3 squared all the way up to n squared. The formula is n into n plus 1 into 2n plus 1 divided by 6. N into n plus 1 into 2n plus 1 divided by 6. Okay, very, very important. We will be doing questions. Third one, the sum of the cubes of first n natural numbers. 1 cube plus 2 cube plus all the way up to n cube. There the formula becomes n square into n plus 1 the whole square divided by 4. Okay, these three are very important. Please do by heart them. Clear? So first one, sum of first n natural numbers n into n plus 1 by 2. Second one, the sum of squares of first n natural numbers n into n plus 1 into 2n plus 1 by 6. And third one, the sum of the cubes of first n natural numbers n squared into n plus 1 the whole squared by 4. Now starting with arithmetic progression. Okay, in arithmetic progression, so what exactly is an arithmetic progression? Okay, so arithmetic progression goes on like this: a plus d, 2a plus d, a plus 2d, a plus 3d, so on and so on. Okay, so what is this a and what is this d? A is the first term of a series. Okay, and d is commonly called as the common difference. Let me give you an example. Okay, we will take the same series, say 1 plus 2 plus 3 plus etc. all the way up to 10. This is an arithmetic progression. Why? Because the first term here is 1. Okay, so A is equal to 1, the first term. The common difference, what is the common difference? Look at this. 2 minus 1 is 1. 3 minus 2 is 1. Correct? Here we have 4. So 4 minus 3 is 1. So difference between the adjacent terms is the same. That is why it is known as common difference. In an arithmetic progression, the difference between adjacent terms will always remain constant. Such a series is known as arithmetic progression. Alright, so if we want to find the sum of first, say 10 terms or n terms, there are very quicker and easier methods to do it. So here in this series, A is equal to 1 and common difference is 1. Why? Because in this series, the common difference between all these is 1 only, right? So A is equal to 1 and D is equal to 1. Understood? So if we want to find the nth term of a series, or if we want to find the sum of n terms, all these are very easily calculated. Okay, again, let's consider the same series, 1 to 10. Okay, 1 plus 2 plus 3 plus all the way up to 10. So according to this formula, how can we find the nth term? So suppose this is the 2, 4, 6, 8, okay, all the way, and we are asked to find the 10th term of this series. Okay, 2, 4, 6, 8, 10, 12, it goes on like that. And we want to find the 10th term of this series. This is a very simple series. So even without all these formula, you can easily find out by calculating. Correct? 2, 4, 6, 8, 10, 12, 12, 14, 16, 18, 20. So answer is 20. So this is very easy. So I am giving this to you as an example. So how would we apply this formula to find the nth term? Okay, so nth term is equal to A plus n minus 1 into D. So here what is A? A is the first term, that is 2. Correct? And what is the common difference? Common difference is 2. D is also 2. Correct? 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So the common difference is also 2. So A is 2, D is 2. Now let's put it here. If we want to find the 10th term of this series, 10th term is equal to A, that is 2, plus 10 minus 1 into D is equal to 2 plus 9 into 2 is equal to 20. Understood? We can find that very easily. So this is a very simple series. If the series becomes complicated, then this is the shortcut. Similarly, the sum of n terms, we can consider another this series. Okay, this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Assume that this is the series. So how would we find the sum of this series? Earlier we studied a shorter formula. That's a common general formula. But in an arithmetic progression, the sum of n terms is given by the formula n by 2 into 2a plus n minus 1 into d, or n by 2 into a plus l. Don't worry, this is very easy actually. Okay, we will look into both these formulas. So I'm going to find the sum of this series 1 plus 2 plus 3 plus all the way up to 10. Okay, this series using the first formula n by 2 into 2a plus n minus 1 into d. So what is n here? Number of terms, that is 10. Okay, so sum is equal to 10 by 2 into 2. What is a? The value of a is 1. In this case, a is 1. The first term is 1. Okay, 2a plus n is 10. So n minus 1 into d. What is the d? Common difference. In this series, it is again 1. So the answer is 10 by 2 is 5 into 2 plus 9 is equal to 55. Okay, this is how we find the sum of terms, n terms in an arithmetic progression. Now, there is another formula, an easier formula, n by 2 into a plus l. Okay, if you know the last term of that series, then you can simply use this formula. In this series, say 1, 2, 3, 4, all the way up to 10, say 10 is the last number in this series. So you can directly substitute it here. So here, if we are applying this formula, n is 10. So 10 by 2 into a is 1 plus l is 10. So again, it becomes 5 into 11, that is 55. Okay, so these two formulas are very, very important for AP, arithmetic progression. To find the nth term, you need the first formula, and to find the sum of n terms, you need the second formula. You can study this one also, which makes life a lot more easier. By heart these three, I have put it in a box, by heart. We will be doing problems based on these. Okay, now comes geometric progression. This is all I'm going to teach you today. Then we are going to do a lot of questions. I am going to wind this class up by 6 p.m. Okay, we will be doing 10 questions today. In the upcoming classes, we will do more and more questions. Okay, since these are the initial classes, I am only taking 10 questions per day. Okay, I'm going a bit slow. So what is a geometric progression? I hope you understood what an arithmetic progression is. Okay, it has a common difference between the adjacent terms. In a geometric progression, instead of a common difference, what we use is a common ratio. Okay, let me explain. For example, consider this series 2, 4, 8, 16, 32, etc. This is an example of a geometric progression. Okay, the difference is not the same. Between 4 and 2, the difference is 2. Between 4 and 8, the difference is 4. Okay, so that we don't say common difference. It is a common ratio. Why? Because 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So that common ratio remains the same, although the common difference is not the same. Okay, so such a series can be represented like this. A, first term, AR, where A is the first term and R is the common ratio, AR squared, AR cube, and it goes on like that. You multiply that term again and again with the common ratio. Clear? So in this series also, we have to find the nth term, sum of n terms, etc., etc. Finding the nth term is very easy. The very simple formula, A into R raised to n minus 1. Say suppose we have to find the 10th term in this series. Okay, 2, 4, 6, 8, sorry, 2, 4, 8, 16, 32. In that series, you need to find the 10th term, which essentially means we have to find the value of, we already know the answer is 2 raised to 10. That is 1024. Applying this formula, how can we find that? So value of A in this series is 2, the starting term, first term. Correct? And what is the ratio? Common ratio? Common ratio is also 2, right? So A is 2 and R is 2. So if we want to find the 10th term, then n is equal to 10. So 10th term is equal to A, that is 2, into R, again 2, raised to 10 minus 1, which is equal to 2 into 2 raised to 10 minus 1 is 2 raised to 9, which is 512, is equal to 1024. Got it? That is how you find the nth term of an geometric progression. Very simple formula. A into R raised to n minus 1. A is the first term and R is the common ratio. Alright. Now, we are going to find the sum of n terms. Alright. In this case, there are two formulas. Okay, why we need two formulas? Because here we have a denominator. Okay, and in this denominator, there is, if you look at this, we have 1 minus R here and then R minus 1 here. Okay, so we have different formulas when R is greater than 1 and when R is less than 1. Okay, otherwise, negative numbers will all come and it will be more confusing. So we have two different formulas based on the value of R. So let's again take the same example and use this formula to find the sum of n terms. Okay, so sum of n terms is equal to A into R raised to n minus 1 by R minus 1. Okay, in this formula, in the formula to find out the nth term, it is A into R raised to n minus 1. N minus 1 is in the power. But in this one, it is A into R raised to n and then common minus 1. It is not n minus 1. Got it? Got the difference? Don't confuse. Okay, so a into r raised to n minus 1 by r minus 1. Why did we choose this formula and not the first one? Because here in this series, the value of r is greater than 1. Correct? R is the common ratio and here it is 2. That is why I picked the second formula and not the first one. Okay, now we can simply substitute the values. 2 into r, the value of r is also 2, value of n is 10 minus 1 by r is 2, okay, is equal to 2 into 1024 minus 1 by 1 is equal to 2 into 1023, which is 2046. So if you add 2 plus 4 plus 8 plus 16 plus all the way up to 1024, the value is 2046. Okay, either you can add that manually or you can simply use this formula and directly get to the answer. Clear? So I hope you understood the difference between what is an arithmetic progression and what is a geometric progression. Arithmetic progression has a common difference, while geometric progression has a common ratio. Just by heart these four formulas, 2 for arithmetic progression and 2 for geometric progression. And you will be able to do a lot of questions. Okay, so now let's start with some of the questions. Okay, so here is the first question. Find the sum of all even numbers less than 75. First question, you have 1.5 minutes to solve this one. Find the sum of all even numbers less than 75. So usually when this question comes in a exam, whatever it is, CSAT or SSC or IBPS, whatever, you will obviously have 4 options. Okay, I have not given the options here because I want you to solve it and find the answer rather than guessing it. When we do the mock tests and all later in the series, I will give you the options and all properly. Some questions have options which I have given in the upcoming slides. So find the sum of all even numbers less than 75. Okay. If any of you got the answer, please put it in the chat. So far, I have not gotten any messages, I think. Last 10 seconds. Okay, time is up. So how do you do this? Find the sum of all even numbers less than 75. So the first thing first, we have to identify whether this is a arithmetic progression or a geometric progression. So let's write some numbers to get it more clear. Sum of all even numbers less than 75. Okay, so what are these numbers? 2, 4, 6, 8, right? All the way up to 74. Less than 75, right? Even numbers less than 75. So it is up to 74. So the last number is 74. Correct? First number is 2. And look at this. Here we have a common difference. Difference between 2 and 4 is 2. 4 and 6 is 2. 6 and 8 is 2. So it is a common difference. So this is an arithmetic progression. Correct? So according to arithmetic, the formula for arithmetic progression, look at this. In order to find the sum of n terms, what is the formula? N by 2 into 2a plus n minus 1 into d, or n by 2 into a plus l if you know the last term. And in this question, we know the last term, which is 74. Correct? So the actual formula is n by 2 into a plus l. We can simply substitute this formula. All right. Now, what is n? How many numbers are there? N is the number of numbers, right? The number of numbers in that series. That is the value of n. In this series, what is the value of n? We can easily find out, right? How can we find the value of n? Because this is an even number progression, a basic arithmetic progression. We know that the value of n is 37. There are 37 numbers. If we count it like 2, 4, 6, 8, 10, like that, if we go on, there are 37 numbers up to 74. We do not have to manually calculate. It is 74 divided by 2. Consider another example. If you are finding out the value of all the sum of even numbers up to 10, then it is 2, 4, 6, 8, and 10. How many numbers are here? There are 5 numbers. Value of n is 5, and it can be easily achieved by putting it like this, 10 by 2. Correct. Similarly, if there are 14, say it's up, if it is up to 14, then the number of numbers, the value of n will be simply 14 by 2, that is 7. So here it is up to 75. So even numbers. So it is up to 74. So the value of n is 74 by 2, that is 37. So directly substituting that value, 37 divided by 2 into a is 2, the first number, plus last number. Okay, and this is equal to 37 into 2 plus 74 is 76 divided by 2. Correct? This is equal to 37 into 38. Correct? So either you can do this 37 into 38, simple multiplication, not much difficult or anything, but there are easier way to do this. If you remember from the last class, I taught you some easier ways to do certain calculations. We did some questions like that. So how I will do this question is like this. Rather than multiplying 37 into 38, I would do like this: 37 into 40 minus 37 into 2. This is easier for me. Right? We can write this 37 into 38 as 37 into 40 minus 2. 38 is 40 minus 2, right? So all we have to calculate is what is 37 into 4 and what is 37 into 2. Very easy. 37 into 4 is what? How much will we get? 30 into 4 is 120. 7 into 4 is 28. So 148. So this will be 1480 minus 37 into 2 is 30 into 2 is 60. 67, 74. So the value will be 1406. Okay. When I explained this, it took some time. But when you do it in the examination hall, this will happen in like seconds. Okay, rather than actually doing a multiplication, you can do it like this. Sorry, 1 second. Okay, Deepika, the answer is actually 1406. Okay, it's not 703. I think you divided an extra 2 somewhere. Correct answer is 1406. Clear? Moving on to next question. Find out the value of this series. 6 plus 15 plus 24 plus 33 all the way to 105. First thing to do is identify the type of the series and then find the value of a and r or n, what r or d, whichever it is, and then find the value of n and do it. 1.5 minutes. 6 plus 15 plus 24 plus 33 all the way to 105. Let's see how many of you will get this. This is an easy question, right? These are simply directly based on formulas. That's it. Now there's nothing more here. Okay. Last 10 seconds. All right, so no answers. Let me tell you how to do this. Okay, slightly complicated in the sense that there is no n. Okay, n is not given directly. Either you can find it out by counting because this is a smaller series, or you can find out the value of n using the formulas. Anyway, okay, we know that a is equal to 6. First term, a is equal to 6. Common difference. What is the common difference? Is 9. Okay, 15 minus 6 is 9. 24 minus 15, 9. 33 minus 24, 9. So common difference is 9. So we know the value of a, we know the value of d. We do not know the value of n. So let n, we can take n as n itself. Okay, and there is a formula in AP that I have already told you to find the nth term. Correct? That formula is what? A plus n minus 1 into d. This is the formula used to find the nth term. Correct? So 105 is the last term given in this series. So 105 we can directly substitute it here. Okay, 105 is equal to a plus, we don't know the value of n minus 1 into d. Clear? So solving this one, I'm taking the 6 here. So it is 99 is equal to n minus 1 into 9. Again, cancelling the common things. Here we have 11. So n minus 1 is equal to 11. Correct? So n is equal to 12. So now we have the value of n as 12. So we got the value of n also. In this question, the value of n was not given. So we have found that out using a formula which gives us the nth term. Okay, so here we assume that 105 is the nth term. Okay, we picked a random term 105 since it's the last term given here, and that nth term is equal to a plus n minus 1 into d, and we already know the value of a and d and this term. So one variable, one equation. We found the answer n is equal to 12. Now we simply put this into the sum of the AP. And since we have the last term, okay, 105 is also L here because it's the last term. We can directly use this formula. Sum of this series is equal to n by 2 into a plus L. Again, that same formula that I had taught you earlier is equal to, what is the value of n? 12 divided by 2 into a is 6 plus L is 105 is equal to 6 into 111 is equal to 666. Got it? Isn't this actually very easy? All you have to do is find the value for a, d and n. Once you have it, you can put it in the equation directly. If you don't have the value of any of these, still you can find that out using one of these equations. That is the beauty of it. Okay, so these are the problems, the kind of problems that you can face. I know slightly more complicated or slightly less complicated kind of questions. CSAT paper, these kinds of questions are usually very easy. Okay, but in certain other exams like say RBI and say CDS, etc., these kinds of questions are slightly more difficult. Okay, but anyway, don't worry about it. I hope you understood the method. That's all what matters. When you get a question based on progression, first identify what kind of progression it is. Is it an AP? Is it a GP? And then based on that, apply the required formulas. Find the value of A, find the value of D or R, find the value of N, and then simply put it in the formula. Okay. Moving on. So this is a question from last class. Okay, I taught you the concept in the last class. Let's see how many of you remember it. So the question is, what is the unit digit in the product of 3 raised to 65 into 6 raised to 59 into 7 raised to 71? Okay, those who have attended my last class, last lecture, knows how to do this. So go ahead and do it. Very easy question. What is the value of, what is the unit digit? Okay, unit digit in the product of this. Last 20 seconds. Try to do it fast, okay? Gradually, you have to increase your speed. Right now, I am going very slow. I will finish the class by 6 p.m. Tomorrow, we have environment, okay? Day after tomorrow, I won't be available. So, I'm preponing that class to tomorrow. I told that in the previous class itself. So, tomorrow, I will be teaching environment first. And time is up. What is the answer? Anyone? Nobody? Nobody gave me the answer so far. Let's see. Okay, I will do this. If you got the answer, good. Otherwise, it's fine. Don't worry about it. So you have to find the unit digit. That is all we need. We do not need the exact answer or anything, which I mean, the full answer would be at least a page length. Okay, so we need to find only the unit digit. So let's rewrite this. 3 raised to 65 into 6 raised to 59 into 7 raised to 71. This is the question. Correct? Now, there is a unique property for 6. This I mentioned in the previous class. What is the property of 6? 6 raised to anything ends with 6, which means the unit digit of 6 raised to whatever it is 6 only. Just think about it. 6 into 6 is 36. Then we have 216. So look, everything ends with 6. So 6 raised to any power ends with 6. Okay, so the unit digit of this particular term is actually 6. Done. We do not have to think about anything. 1 second, I'm getting a call. 1 second. Sorry. Okay, sorry for that. All right, so unit digit of 6 raised to whatever it is 6 only. Okay, that is done. Now, regarding 3 and 7. This also I explained in the last class. Let's check the powers of 3. Okay, so 3 raised to 1 is 3. 3 squared is 9. 3 cube is 27. 3 raised to 4 is 81. Correct? 3 raised to 5 is this one into 3. That is 243. And 3 raised to, again, next one is 729. And it goes on like that. Look at this series. 3, 9, 7, 1. Again, 3, 9, next will be 7, and then next will be 1. So this keeps on repeating. 3, 9, 7, 1, 3, 9, 7. So the unit digit will have only these 4 values. Okay, so this is 3 raised to 1. This is 3 raised to 2. This is 3 raised to 3. This is 3 raised to 4. Let's arrange this. Okay, 3 raised to 4 into, how can we split 65? 3 raised to 65 can be rewritten as, okay, let me write here. 65 is equal to what? 4 into how much? 16 plus 1. Correct? 4 into 16 plus 1 is 65. So 3 raised to 4 into 16 into 3. Okay, we can write 3 raised to 65 as 3 raised to 4 the whole raised to 16 into 3 raised to 1. Correct? Any doubts there? Why are we putting it into the powers of 4 or into the multiplication of 4? Because it is the 4th power that has 1, that ends with 1. So if we have anything that ends with 1, the powers of that will also end with 1. Think about it. 1 raised to everything is 1. 11 raised to, say, 11 raised to 1 is 11. 11 raised to 2 is 121. 11 raised to 3 is 1331. So if the unit digit is 1, then its powers will also end with 1. Okay, so here if we put it like this, what is the advantage? 3 raised to 4 is 81. So any power of that, the unit digit will be 1 only. Clear? So we can easily solve this. So 3 raised to 4 the whole raised to 16 into 3 raised to 1. So 3 raised to 4 is 81. The whole raised to 16 into 3 to the power 1. So this term, 81 raised to 16, the unit digit of this will be 1 into 3 raised to 1. And we have the 6 from here. So I am directly putting it here. And now we have to find about 7 raised to 71. What is the unit digit in 7 raised to 71? Again, the same procedure. How will the powers of 7 progress? It is 7, 49, 343, 2041. Okay, and then again it will continue 7, 9, 3, 1. So this is another property of 7. After every 4 iterations, the unit digit will be will be repeating again and again. Okay, so here also we do the same thing. Because you have 1 in the end of 2041, we convert this 71 into the in terms of powers of 4. Okay, so we can write 70, here we have 7 raised to 71, right? So 71 can be written as, how can we split 71? 4 into what? How much time will it go? 4 into 17, I think, plus 3. Okay, so we can write 7 raised to 71 as 7 to the power of 4, the whole into 17 plus 7 raised to 3. 7 to the power 4 is 2041. So 2041 to the power of 17 plus 7 cube. So because the unit digit is 1 here, any power of that will also end with 1. So the unit digit in this term will be 1. Plus 7 to the power of 3 is what? 343. Okay, which means the unit digit is 3. So we can simply calculate 1 into 3 into 6 into, sorry, this is into, okay, 1 into the unit digit only, 3. So 3 into 6, 18 into 3 equal to 54. So the answer we want is 4. The unit digit in the product of these three, this complicated question is actually 4. I hope you understood it. Anyone has any doubt in this one? Please let me know. Do you want me to explain anything again? If you want, I will explain it. Otherwise, we will move on to the next question. Did you understand the idea on how to solve this? If we get such big powers, you have to understand that it is possible to group it into something shorter. Okay, 65 can be rewritten as 4 into 16 plus 1. Similarly, 71 can be grouped as 4 into 17 plus 3. Okay, and then you can simply bring down the complexity level to something very easily calculatable. So this is how you solve this problem. So the correct answer to this question is 4. The unit digit in the product of this is 4. So nobody has any questions, I think. No comments. So moving on. Next question. Again, based on something we learned in the last class. If the number, this one, is sorry. 1 second. Oops. If the number 4573p is exactly divisible by 72, then the minimum value of p is what? That is the question. Okay. So far, no comments. I hope you are getting it. If there are any questions, please feel free to ask. Okay. So divisibility test we studied yesterday. I hope you remember. So try to convert it in those terms. All right. 70, we do not have a standard method to check whether a number is divisible by 72. Okay. So we can actually manipulate 72 into something that we learned yesterday and then easily solve this problem. Last 30 seconds. So it's already given in the question that this number is exactly divisible by 72. All we have to find is the unit digit, that is value for p, the minimum value for p. Time is up. Okay, so again, nobody answered this. If any of you want more time, just ask me. Okay, if you are doing it and you need some more time, put it in the chat and I will give you some extra 30 seconds. All right. But anyway, I'm going to answer this one. This is how we do it. Okay. So we do not have a standard test for divisibility of 72 or anything, divisibility by 72 or anything. So how would we rewrite 72? We factorize 72 as 8 into 9. We know the divisibility test for 8 and we know the divisibility test for 9. And what is the unique property of 8 and 9? 8 and 9 are co-primes. I hope you remember. What are co-primes? Co-primes are those numbers and those, A and B, such that the highest common factor of these two numbers is 1. Correct? Highest common factor between 8 and 9 is 1. So 8 and 9 are co-primes. So that is to our advantage. We can factorize 72 in a lot of ways. We can write it like 36 into 2. Correct? Or say 18 into 4. That is also 72. But the problem is if we take 18 into 4, then 18 and 4 have many common factors. Their HCF is actually 2. But here, why we are taking 8 and 9? It is because 8 and 9 has the HCF 1. They are co-primes. So they do not have any common factors other than 1. Clear? Which makes it easier for us to calculate. So whenever you get these kinds of questions, divisibility by a higher number, try to convert that number into a product of co-primes, if at all possible. Okay, usually it will be possible. So here we have converted 72 as 8 into 9. Now all we have to do is simply check divisibility of 8 and simply check divisibility by 9. So how do we check the divisibility by 8? If you remember from yesterday's class, to check divisibility of 8, what we do is the last 3 terms should be divisible by 8. Sorry, last 3 digits should be divisible by 8. Okay, the number formed by the last 3 digits, that is 73p. This should be exactly divisible by 8. So what is the value of p which makes this number exactly divisible by 8? That is the question. So let's try it out. Okay, 73p divided by 8. So 9 8s are 72. Balance is 1. So remainder is 1. And now I have p. So what is the value of p that I can put here so that this will be exactly divisible by 8? Can I put p as 1 here? If I put p as 1, then it will be 11, right? So 11 is not completely divisible by 8. Then p is 2, 12, no, 13, no, 14, 15, 16, yes. So if I put p as 6 here, then it is 2 8s are 16, perfectly divisible, no remainder. So the value of p is equal to 6. Okay, so now we proved that it is divisible by 8. Now, in order to make it 100% sure, we can check the divisibility by 9. Okay, we have checked the divisibility by 8 and now let's check the divisibility by 9. How to do that? What was the method? In order to check the divisibility by 9, you have to add the digits and check the sum. Check if the sum is divisible by 9. So 4 plus 2 plus 5 plus 7 plus 3 plus p. Okay, and the value of p is 6. So 6 is equal to what? 4 plus 2, 6 plus 5, 11 plus 7, 18 plus 3, 21 plus 6, 27. And this is exactly perfectly divisible by 9. So this number, okay, 4, 2, 5, 7, 3, 6 is perfectly divisible both by 8 and by 9 and hence divisible by 72. Alright, so the value of p is 6. I hope you understood this one. Do anybody has any doubts? Yeah, Deepika got it. Very good. Anyone else? Any doubt? Okay, this is all you have to do. When you get such divisibility by a very high number, try to convert that number in terms of co-primes. We have converted 72 as 8 into 9. Clear? And then check the divisibility of each of these and then you will easily find the answer. That's it. Very simple question. Moving on. If A and B are odd numbers, then which of the following is even? Very simple question. You do not need 1.5 minutes, but I will give you anyway. I'm going to be a bit more faster. This is a very easy question. I will explain this very quickly. I have to finish it at least by 6:05. Okay. If A and B are odd numbers, then which of the following is even? Option A plus B. Option B, A plus B plus 1. Option C, AB. Option D, AB plus 2. Deepika is saying A. Option A plus B. Anyone else? Only one person is actually answering. Anybody else? Please feel free to put it in the chat. If you get it wrong, doesn't matter. Okay. We are here to learn, that's all. These kinds of questions are also being asked in CSAT. In the most recent one, in CSAT 2021, there was a question that went something like this. Okay, you are not given any values or anything as such. Instead, you are given some variables and you have to find the answer in terms of that variables. So that is why I put this question also. So it is given that A and B are odd numbers. Okay, so let's take some examples and do it. Okay, so let A is equal to 7 and let B is equal to say 9. Okay, so if A and B are here, both A and B are odd numbers. So what is the value of A plus B? A plus B is 16. Correct. A plus B plus 1 is equal to 17. AB is equal to what? 7 into 9, 63. And AB plus 2 is equal to 63 plus 2 is 65. So here we have only one. So this is the easiest way to answer this. Correct answer, very good Divya, it is A plus B. Okay, so there is a property for addition and subtraction and multiplication of odd and even numbers. Odd plus odd. Plus or minus, okay, odd plus or minus odd gives you what? Odd number plus or minus an odd number will always give you an even number. Odd number plus or minus an even number will always give you an odd number. Even number plus or minus an even number will always give you an even number. This is a common property. Either you don't have to by heart this because it's logic, it's common sense. Similarly, there are some properties for multiplication also. Odd number into odd number is odd number. Odd number into even number. Okay, 7 into 2, that is even number. Even number into even number is equal to even number. By heart these properties and you can easily find the answer to these kinds of questions. Clear? Moving on. Which one of the following is a prime number? Okay, here we go. Time starts now. Yesterday, I taught you the procedure to check how to check whether a number is prime number or not. Which one of the following is a prime number? Option A 119, option B 187, option C 247. Option D, none of the above. Last 30 seconds. Okay, Divya is saying it is D. None of the above is a prime number. All right. Anyone else? Time is up. So how do we do this? Let's check one by one, okay? But the easiest way to do this is to go for the biggest number first. Okay, so let's take 247. If you remember from yesterday's class, I mean day before yesterday's class, the test for prime number goes on like this. Okay, if the given number is equal to p, okay, p is equal to 247, then we have to find a value for n such that n square, sorry, again there is an issue with my pen. I'm really sorry for this. One second, guys. It's not working. One second. Okay, so we have to find a value for n such that n squared is greater than or equal to p. Okay, so what is the value here? What is the value of n that we can take here? Anyone? If p is 247, then what is the value for n? I told you to by heart the squares of at least first 25 numbers. If you had done that, you will definitely get this very quickly. What is the value for n that goes here? 16, correct, Deepika? So if we take n is equal to 16, then n squared is equal to 256, which is greater than our value p, that is 247. So our value for n is 16. So what is the second step? Write down all the prime numbers less than n. So less than 16. So 2, 3, 5, 7, 11, and 13. These are the prime numbers less than 16. Now check the divisibility of that number with this. Okay, why did I go for the biggest number directly? Otherwise, you will have to, every time you will have to repeat the whole thing again and find different values for n. By directly going for the biggest number, we have to find the value for n only one time. That is why I did that. Okay, so first number, let's check each of these numbers. First number is 190. Is 190 divided by perfectly divisible by 2? No. 3, divisibility for 3. How do we do it? Add the digits and see if the sum is divisible by 3. So 1, 1 and 9. It adds to 11. 11 is not divisible by 3, so no. 5, no. 7, yes. Okay, 119 is divisible by 7. You can check it also. 119 divided by 7. 1, 4, 49, and 7. Perfect. So this is not a prime number. Second one, 187. Is it perfectly divisible by 2? No. 3. Okay, 7 plus 8 is 15 plus 1 is 16. 16 is not divisible by 3, so no. 5, no. 7, 4, 47, no. 11, yes. 187 is perfectly divisible by 11. What will we get? 187 divided by 11 gives you 17. Okay, then so this is also not divisible, not a prime number. Third one, 247. 247. Is it divisible by 2? No. 3? No. 5? No. 7? No. 11? No. 13? Yes. You can directly identify it very quickly. Why? Because 13 into 2 is 26. So 13 into 20 is 260. And here is 247. So it is 13 into 19. Okay, that is how you process it in your head. So this is equal to 13 into 90. Perfectly divisible. So this is also not a prime number. So the correct answer is D. None of these given are prime. Alright, moving on. On dividing a number by 68, we get 269 as quotient and 0 as remainder. On dividing the same number by 67, what will be the remainder? Don't panic. This is not a complicated question. I will give you a clue. This is how you do it. This formula. Sorry. Yesterday I taught you this formula. Use that to get the answer. Last 10 seconds. Time's up. Anyone? Nobody got it so far? I thought this was a fairly easy question. Okay, don't worry. Let's do it. Okay. So, on dividing a number by 68, we get 269 as quotient and 0 as remainder. Okay, so we do not know what that number is. Okay, that is the dividend. Okay, we do not know what that is. Quotient is 269 and divisor is 68 and remainder is 0. Okay, now we know what that number is. 269 into 68. Let's do it. Okay, 269 into 68. Okay, how do so 9 8s are 72, 7 and 5 21. Okay, and then multiplying 269 by 6, we have 9 8s are 64, 4 1 and 16. Okay, now adding 2 9 2 8 1. Okay, 18292. That is the product of 269 into 68. So that is our dividend, 18292. We got the number. Now we have to divide this number by 67 and find the remainder. That's all. Very simple. So let's divide 18292 by 67 and let's find out what is the remainder. Okay, so 67, so it goes 2 times. 2 into 67 is 134. Balance is 48. We bring down 9 and then we have 6 times. No, then 7 times 8. Okay, 8 times does not go, so 7. 7 times 67. 7 times 49, 9 and then 6, 4. Okay, so balance is 20 and we bring down 2 and so 367. Okay, so 3 into 67 is 201. Okay, so 201. So the remainder is 1. That is our answer. Clear? What we have to find out is the remainder when this number is divided by 67. So the answer is 1. 202 minus 201 is 1. Got it? How you do it? All you need to know is this formula. Dividend is equal to quotient into divisor plus remainder. We have the quotient, we have the divisor, we have the remainder. From that, find the dividend. And simply divide that number using the new divisor. Find the remainder. Done. Alright, moving on. A number, when divided successfully by 4 and 5, leaves remainder 1 and 4 respectively. When it is successively divided by 5 and 4, then the respective remainders will be dash. I'm slightly going faster. It's already 6. That's why I'm taking it a bit quicker. Okay, in next 5, 10 minutes, I will finish this. I request all of you to put your answers in the YouTube live chat. whether it is right or wrong doesn't matter. Last 30 seconds. Same rule as the previous one. Time's up. Anyone? No? Okay, this is how we do it. Okay, so a number when divided successively by 4 and 5 leaves remainders 1 and 4 respectively. That is what it's saying. Let's divide and let the number be x. Okay, let the number be x. We are going to divide x successively by 4 and 5. So let's divide x by 4 first. Okay, so when x is divided by 4, what is the sorry, let me just make it a bit more easier for you to understand. Okay, let the number be x and let's divide x by 4, initially by 4 and then by 5. So when x is divided by 4, we will get something, some value. Okay, let's say it's y. And what is the remainder? Remainders are 1. Okay, now we have to again divide this y by 5. Right, it says that successively by 4 and 5 leaves the remainders 1 and 4. So here what we do is we assume that the quotient is 1 and the remainder is it's given as 4. Okay, let me tell you one, repeat this once again. Assume the number be x. According to the question, we have to successively divide the number by 4 and 5 and we will get the remainders 1 and 4 respectively. So we are dividing x by 4 and we get some answer, let it be y, and the remainder is given as 1. And now we divide this again by 5 and the remainder that we get is 4. We assume that the quotient is 1 this time. For easy calculations, we assume that the quotient is 1. Now use the same rule as I have mentioned earlier. Dividend is equal to divisor into quotient plus remainder. That is the exact thing that we have to use here. So using that, how can we write y? Y is equal to, y is the dividend here. Okay, in this section, y is the dividend. So y is equal to quotient is what? 1 into remainder, divisor is 5. So 5 plus remainder is 4 is equal to 9. We got the value for y as 9. So what is x? X is equal to divisor in, quotient is y. So y into divisor plus remainder. So y, the value of y is 9. So 9 into 4 plus 1 is equal to 9 into 4, 36 plus 1 is 37. Okay, so that number is 37. Now all we have to do is divide it by 5 and 4 and find out the remainders. So we are going to divide 37 initially by 5. So it is 7 5s are 35 and balance is 2. And then we divide this by 4 and we get quotient as 1 and balance as 3. So the answer is 2 and 3. The remainders are 2 and 3. Did you understand how we do this? The only formula that you need to know to do this question is dividend is equal to divisor into quotient plus remainder. Okay, I hope you understood. Nobody is telling me anything. So I think you understood and hence I am going to move on. If any of you need more explanation, just tell me, okay? Next one. A number when divided by 296 leaves 75 as remainder. When the same number is divided by 37, what will be the remainder? Same question, same method, do it. Yesterday, I did a question exactly like this. Today the numbers have changed, that's all. I think just there are only 2 more questions. We will finish by 5 minutes. Okay, within 5 minutes we will. I'll give you one question as homework. You can do it, and then we will do one here. Last 25 seconds. Nobody again got to no one. Okay, so let's see how to do this. A number. Okay, we do not know that number. So let's again divide it by 296 leaves the 75 as remainder. So what is the remainder when it is divided by 37? That is the question. So again, same formula. Dividend is equal to quotient into divisor plus remainder. Okay, so is equal to dividend means that number. Okay, so it is equal to q. Quotient is q. We do not know quotient into divisor is 296 and remainder is 75. So this is the number. Yesterday we did a similar kind of question, right? Where we got the number in terms of q. Correct. So 296q plus 75. This is our number. Now we have to divide this number by 37 and find out what is the remainder. That's all. So what we have to do is to write this number in terms of 37. And we will find that there will be some value which we cannot put it in terms of 37. So 296 can be written as 37 into 8. You can check it out, okay? I'm doing it faster because we are already about time. Okay. So 36 in 7 into 8 q plus, how can we write 75 in terms of 37? 37 into 2 is what? 74 plus 1 is 75, right? So I am writing it as 37 into 2 plus 1. Okay. So if you look at this term is perfectly divisible by 37 because there is a 37 here. So if we divide it by 37, we can cancel that out. This term is also perfectly divisible by 37. So what is the remainder? 1. So when you divide this number by 37, the remainder that you get is 1. So the answer to this question is 1. Understood? Don't worry, you do not have to find the full number. You can find the number in terms of q or r or whatever and then work on that. Okay, moving on. The sum of how many terms in the series is 1800. Last question I will give you as homework. Okay, do that at home. I will show you that question and do it yourself. If you have any questions, tell me, let me know. Otherwise, we will take that question in the next class. Okay. I will definitely work out that question in the next class, at the beginning of next class. But this is the last one we are going to do today. Sum of how many terms in this series is 1800. So basically we have to find the value for n. That's it. Identify the type of series. and apply the corresponding formula. That is all you need to do. "25 seconds remaining." Okay, time's up. So how to do this question? First of all, identify the type of series. Okay, 6 plus 12 plus 18 plus 24, etc. So what kind of series is this? This is an arithmetic progression. Why? Because there is a common difference. 12 minus 6 is 6. 18 minus 12 is 6. 24 minus 18 is 6. So we have a common difference. So there is a D, and the value of D is 6. What is the value of A? A is the first term. So A is equal to, here A is also 6. Correct? And we have sum. Okay, let's put sum equal to S. S is equal to 1800. Now all we have to do is find the value for n. Very simple, right? So what is the formula for a sum of arithmetic progression? Sum is equal to S is equal to n by 2 into 2a plus n minus 1 into d. This is the formula. I asked you to by heart this. So let's simply substitute all the values. So 1800 is equal to, we do not know the value of n. So let's put it as n itself, into 2 into, what is the value for a? It is 6. Plus, we do not know the value for n. So n minus 1 into, what is the value for d? It is 6. Now let's solve it and find the value for n. That's it. So this one is equal to n by 2 into 12 plus n minus 1 into 6. I will put it like this because we can cancel out later. Okay, now is equal to, if we open the brackets, it will be 12n by 2 plus 6n into n minus 1 by 2. We can cancel these out, 6n, and this also goes, correct, is equal to 6n plus 3n into n minus 1. Correct? Now we have to open this up, is equal to 6n plus 3n squared minus 3n. Alright, now we can rearrange this as into a proper formula. So 3n squared plus 3n. Did I miss? No, this is correct. 3n squared plus 3n. Correct. So 1800 is equal to 3n squared plus 3n. Let me write it at here. Okay, I'm going to continue this at the top. Okay, I'm going to do it here. So 1 second. Okay, 1800 is equal to 3n squared plus 3n. We can take 3 as common. So 1800 is equal to 3 into n squared plus n. So 3 and 1800 cancels, and this is 600. Okay, so 600 is equal to n squared plus n. Alright, so if we rearrange this, n squared plus n minus 600 is equal to 0. Correct, that is the equation. Now we have to solve for n. So do you know how to factorize an equation? I hope you know that. You have studied that in school. So the product sum is 1 and the product is 600. Okay, that is how you find the factorization. If you don't know that, please do learn it. I'm going to do it anyway. So n squared plus 25n, 25 into 24 is 600, right? 25 into, yes, so 25n minus 24n minus 600 is equal to 0. Why did I put it as 25 and 24? Because the sum of 25 and minus 24 is 1, and the product 25 into 24. So 25 into minus 24 is minus 600. So the product is minus 600 and sum is plus 1. That is how you factorize. That is something that we study in school. I hope you know it. Okay. So again, now we just take out the common values and find the answer. N into n plus 25 minus 24 into n plus 25 is equal to 0. So n minus 24 into n minus 25, n plus 25 is equal to 0. So n is equal to 24 or minus 25. N cannot be negative, so the answer is 24. Okay, slightly confusing, I know, but if you know how to factorize, that's all. Simply use the formula, find the value for n. But in order to find the value for n, you need to know how to factorize a linear equation. Sorry, a quadratic equation. Okay, if you don't know that, just try to learn it. Here, the method is simply the product is minus 600 and sum is plus 1. Okay, so that is it. We are ending the class here today, but you can I will give you one question as homework, or maybe I will take it in the next class. Okay, it's slightly different, so I'm going to take that in the next class. Don't worry about it. I'm ending it right here for now. Thank you all for joining. If you have any queries, please feel free to ask me. You can contact me personally through Telegram or WhatsApp or Insta or Facebook. Okay, all the links are given in my Telegram channel. The link is here, t.me/msrw1. Okay, so that's it for today. Thank you all for joining. See you again tomorrow with the first chapter of environment and ecology.